Okay, I think I'm audible. So I'm going to go ahead and begin this presentation. So welcome to Cloud Clinic 6. This is the sixth of a series that we plan to continue as the CloudBank organization. CloudBank is an NSF-funded collaboration between three universities: University of California, San Diego, University of California, Berkeley, and the University of Washington, which is where I'm located. And our goal in this program is to facilitate access to commercial cloud, public cloud, so clouds such as AWS and Microsoft Azure and Google Cloud Platform, for the purpose of academic research. And the idea being that there are aspects of cloud computing that can really facilitate research, for example, through access to basic resources like computing and network speed and storage, and access to higher level abstractions such as AI tools and various other things that you might want to build and use in the course of doing research computing. So that's what CloudBank is all about. And this Cloud Clinic series is part of our Education Outreach Training Program. And so I drive that together with Sarah Stone at the University of Washington. And the purpose of these Cloud Clinics is to do sort of a bite-sized presentation of a cloud technology that's commonly useful and might, to a person who's new to cloud computing, be a little bit mysterious. And so we're trying to demystify and make these technologies more accessible to someone whose research focus might not be in computer science, but who needs to get something built in order to make progress. Okay. And so I will continue onwards here. Welcome, Jose. And make that a little bit smaller. So I'm apparently a person with disheveled hair. I am a technology learner, but not a computer scientist. My background is in geosciences, but I do advocate for open data science. And so the general plan here is to sort of review the cloud clinics that we've done so far briefly, and then to sort of launch into a short presentation on today's topic, which is called Bouncing Virtual Machines. So we're trying to do bite-sized stuff. I think I've pretty much said this. But one thing I want to re-emphasize or keep emphasizing is that you can spend $1 on the cloud, or you can spend $20 on the cloud for the same result. And obviously, if we have a finite budget, we want to learn how to use $1. And also, we want to be able to accumulate a familiarity with cloud technology and particularly security, so that the stuff that we build isn't at risk of being damaged. Here's the list of the clinics we've had so far. The very first one concerned preemptible instances. This is sometimes called the spot market, and that can give you a 75% savings on your spend. We talked in Clinic 2 about data publication and creating API access to data sets, the so-called shoebox full of data tapes problem. Clinic 3, we discussed Docker containers. Clinic 4, we talked about connecting object storage to a laptop. And very briefly, object storage is a slightly different type of storage that's available on the cloud. It has an enormous capacity, but it doesn't have sort of open and seek capabilities for individual data files. So it's treating data files more like hermetic objects. But we went through the process of connecting a object storage bucket, an S3 bucket, to a laptop so that it appears to be a data drive. And that's kind of cool to have a large data set sitting on the cloud, but appearing to be local, so that you can access it through local means. Clinic 5 discussed the Littlest Jupyter Hub, which is an easy-to-build version of Jupyter Hub that does not involve containerization or multiple servers or Kubernetes or anything like that. And then today's clinic is about bouncing virtual machines. And we'll try and describe what that is and why we would want to do it. So this is a slide that has links to those different presentations. And all of this stuff is supposed to be available on the web at cloudbank.org. That's our CloudBank project website. And I'll also mention, and this comes up again at the end too, if you have questions about today's presentation or anything about CloudBank, you can email help@cloudbank.org, and we will turn that into a support ticket and try and help you out. Okay, so let's see. To bounce is an audio production term meaning to make a copy of an audio track, but we're going to be bouncing not audio tracks, but virtual machines. So that's the goal. I like to start these clinics by stealing my own thunder and describing what's happening, both in high-level detail. So I'll just read this. Let's say you want to build a virtual machine on the cloud, but the amount of compute power you need is a lot. Maybe the cost-effective way to sneak up on that would be to build a virtual machine with your working environment set up, and then save this as something called a machine image, which is like a snapshot of that virtual machine. It's not, the snapshot is not itself a virtual machine. It's like a big, huge file. And then once you've saved it as a machine image, you can restart that virtual machine, but on a different, more powerful piece of hardware when you're actually ready to use the compute power. So that's the stealing the thunder of today's Cloud Clinic. And then there's no need, once you do this restart, to rebuild the working environment. It's already there and baked in. And you can restart one virtual machine with this baked-in working environment, or you could restart 10 of them if you'd like. I'm going to skip over all this fine print here, except to point out that creating a working environment on a virtual machine might involve things like installing libraries, importing data sets, developing code, making sure that it runs, comparing the results of a virtual machine run to running the same job locally on your own computing resources, and then doing things like managing your code base by pushing your changes to your code to GitHub. And this is all part of the working environment development that we're describing here. Okay, this is also a lot of text, but very briefly, today's recipe is to create a virtual machine and log into it. Do some minimal configuration. So we're not going to go into these sort of extensive steps of installing Python and mounting S3 buckets and copying data and running programs. We're not going to do that. We're just going to do the absolute sort of minimal configuration step to demonstrate that we have, in fact, visited a virtual machine and made some changes to it. And then once we do that, we're going to make an image of the virtual machine. We can terminate the original so there's no trace of it, and then restart the image on a more powerful virtual machine. And there's a little finesse here, which is that it's better to restart the image and make sure that the new virtual machine does, in fact, have a copy of the original working environment before terminating that original one. Because sometimes, at least for me, I can make mistakes. Then just check and see that everything is present. And then, of course, if you were doing this in a research context, you would want to, let's say, time a compute job on both the initial machine and then on the more powerful machine, and convince yourself that you are, in fact, getting the bigger compute horsepower that you were going for. And the time to do this sort of back and forth, let's say the first time you're doing it is sort of 4 hours, and that's just kind of a high estimate of time that would be required. Once you're used to building machine images to bounce a virtual machine from a smaller machine to a larger machine or vice versa, it's a matter of just a few minutes once you're familiar with it. I'm also going to make a quick aside comment on resource management and launch templates, which are more sophisticated ways of accomplishing the same kind of stuff we're doing here. We're doing it by hand, and we're using the AWS console. And I'm doing it in a cooking show fashion where I'm not really actually going to be banging through the various steps on the console, but rather I'll be using screen captures from a recent session where I did the various steps. And so that's the sort of by hand mechanism of building this virtual machinery. And then there's also the opportunity to expand one's, let's say, depth of skill into the cloud by using resource management services such as something on Amazon Web Services called CloudFormation. So I'll mention that briefly. So without further ado, now that I've described everything, if it's all clear to you and you've got the idea, feel free to drop off. I'm just going to keep on going on here, or if you have any questions, of course, feel free to interrupt me. So off we go. This is now a screenshot from the Amazon Web Services console. That's the web browser interface to the Amazon cloud, and you have to log into this and authenticate. And when you authenticate, you also want to be sure that you're in a region. That is to say, the cloud is divided up into multiple regions that are spread across the globe. And I'm in Seattle, so I will use the US West 2 region, which is in Oregon, and that gives me the shortest communication latency when I talk back and forth to the cloud and build stuff. So here we are. And if you're not familiar with the Amazon cloud, the term for a virtual machine on Amazon that varies from cloud to cloud is EC2, which is Elastic Compute something, Elastic Cloud Compute, I think. So that's a virtual machine, and you can see that there's no instances here. So I will continue onwards with my quest to create a new image by clicking on the Create Image. And now we go through a wizard that allows us to specify which virtual machine we want. So now we're taking the first step of creating a working environment, which is to set up a virtual machine. And you can see that I get to choose an operating system, and the operating system I use points to this lower sort of oval where it says AMI-03AA, etc. And AMI is Amazon Machine Image. So I'm actually pointing my browser to a vanilla Ubuntu operating system that is itself a machine image of an Amazon virtual machine. I've also included on the right-hand side of the screen here the on-demand Ubuntu pricing. This is for the operating system I chose. It's going to be 9 cents per hour. So I'm getting a fairly wimpy machine. In fact, it's called C5.large. It's on the low end of workstation machines that you can get on the cloud. Continuing on with the browser, there is a step involved where I give my machine a name, and I also get a key pair. So I've called this machine small worker, and then the key pair name I've generated is just called worker because I'll be using that key pair, which serves the purpose of a password, but it's an authentication file. And I'll be using that for both the initial machine and then the rebuilt, more powerful large worker machine. I use the .pem file format, and some of the details are blurred out here because they're not important. But the next thing I want to describe here is on the right-hand side of the screen, which is the choice of a security group. On the Amazon Web Services cloud, you create resources like a virtual machine, but they are always contextualized to a security group so that you can create rules around their use. And I'm using the default existing security group, which has some kind of a designator, but I'm about to fall I'm about to hit a pitfall of using security groups, which is that security groups, when they have objects in them that you can connect to, like a virtual machine, they have rules associated with whether or not you can connect. And I will be connecting using the secure shell, so SSH. And when I select this default security group that places my new virtual machine into that security group, so far so good, but there is no rule for SSH, and so I can't actually connect to my virtual machine. But I didn't know that when I was doing this, so I just kind of blundered along. And now let's continue on with the steps to launch the virtual machine, because I'm not going to run into that pitfall until after I've launched it. The default root disk volume is 8 gigabytes on this particular machine, and I took a moment to increase that to 32 so that I would have some onboard data storage capacity. And you can also add additional drives to the virtual machine. Okay, so I mentioned I was going to do an aside about resource management. And the first part of the aside is a two-part aside. The first part is that instead of using the browser-based console to interact with the cloud, I can use a command line interface. And the command line interface is something that I would install on a Linux environment. And the command line interface is activated by the command AWS. So you can see the red circle there around AWS. And what I did here was, as I was going through the wizard to configure the virtual machine, I noticed that there was a console to code option, and I clicked on that, and it gave me, that's what this big, huge box on the right-hand side is. It gave me a large command starting with AWS and then EC2, and then run instances. It gave me this command, and this command would basically be something that I could run on my computer that would do the same thing that I just did using the wizard. So the wizard configures creating a virtual machine, and this command will do the same thing, but I can run it from my command line instead of logging into a console. So that's the sort of first step in the aside of automating the production or the allocation of resources on the cloud using the AWS command line interface, okay? And so this command line interface has some authentication stuff built into it, and I won't belabor that, but the point is, once you have it up and working, you can just cause a virtual machine to jump into existence from the command line. No browser messing around with a wizard is necessary. So that's the first part of the aside. The second part of the aside is that you can go a little bit further and use a service in AWS called CloudFormation, which allows you to build templates and then submit them to a service. The service is called CloudFormation, and that creates and manages resources on AWS. And so the way that that works is it uses a form of YAML, the markup language, or not a non-markup language, I guess. And CloudFormation is then a way to auto-generate infrastructure. There's another service called Config that allows you to monitor that infrastructure once you have it up and running to sort of make sure that it stays within some kind of conformance or some guidelines for operation. But that's just something I wanted to mention, that you can go from using the browser and a wizard to click on and form a virtual machine to using the command line interface to using a resource management service like CloudFormation. And these things exist on all the clouds, and there's a slide further down that gives the equivalent jargon for the other two major clouds. So now we've gone through this aside, we're done with that. We've configured a virtual machine, and we get to a button called Launch Instance, and we click on that, and suddenly there appears on the cloud a instance, a virtual machine, which is our small worker. And that small worker is what we're going to be configuring as our working environment. So I mentioned that we had placed that small worker EC2 virtual machine inside of a security group, or SG, and then tried to SSH to that virtual machine, and just completely didn't get anywhere. It just completely failed. And the reason for that is that the security group didn't have a rule in place admitting SSH traffic on port 22. So I went back into the console and I navigated to the security group, and I created a new rule that is called an inbound rule that does in fact permit SSH on port 22. And so the screen cap below shows the results of making that modification. Everything's good now, and now I can log into that virtual machine. Okay, so I'm going to set this slide deck aside for a moment, and I'm going to go to, let's see, give me a moment. Yeah. Okay, so this is a instance of VS Code, Visual Studio Code, and I've used the button at the lower left, which is these sort of greater than, less than signs, and it now says SSH 3594, etc. I've used that little greater than, less than to create a SSH tunnel to my virtual machine on the cloud. So that's why when I come up here to the terminal window, it says Ubuntu at IP 172, et cetera. That IP address is not the public IP address that I used. It's an internal to AWS private IP address. But the point is, I'm now sitting on a, whoops, no forwarded ports. What happened here? Oh, I clicked the wrong thing. Okay, so here I am with an Ubuntu prompt. So this is Linux on the AWS small worker virtual machine, which AWS likes to call EC2. And if I hit return, it'll just give me an error. So the point is, we are sitting on a terminal line, a bash shell, a board again shell, on the cloud virtual machine called small worker. And if I say ls, I find out that there's two files here. I've already created these files earlier. And in fact, the commands that I've issued are back on the slide deck, and I'll go through those in a second. But the point is that there's a file called a.c. If I look at its contents, it's a single print statement. And I've compiled it using gcc-o a.c. And then I can run the program A, and it'll do that print statement and say, here's some data, 1, 2, 3, et cetera. Okay, so hopefully that's a convincing argument that I'm on a cloud virtual machine, and I'll go back to my slide deck and proceed from there. So I described the steps that I took. I ran a sudo apt update and upgrade, and then I installed the GNU C compiler. I edited the a.c file, put in the print statement, compiled that code, and then ran that code, and it printed a little message. And it's not terribly exciting, but it is at least a minimal amount of modification of the work environment. So I can see if my bounce action is successful later on. So now I'm going to return back to the browser-based interface, the Cloud Console for Amazon Web Services. And I'm going to go to, as you can see up in the upper left, it says EC2 instances. So this is the dashboard interface to the virtual machines that I'm running. There is only one called Small Worker, and it is currently running. That's its instance state at the center of the screen. And it is a fairly small machine. It is a C5.large. And now I'm going to use the the actions menu, which is up at the upper right and has a red oval around it. So the actions menu, I click on that and it does a drop-down menu, and there's the choice of image and templates. And if I click on image and templates, it sort of confusingly pops up a sub-menu, which is just to the left of that, where we have the option to create an image. So I've created an EC2 virtual machine. I've made some modifications to it. And now I'm going to create an image of that virtual machine. So that's what this screen is showing. There's quite a lot going on here. So what happens when I select create an image? Well, let's see, the console has created the EC2 instances. I'm just kind of reiterating what I just said, so I'm going to move on from here. Okay, so now there's a new image that's going to happen, and here's a little bit of a finesse in my narrative. Earlier in this narrative, I described going through a bunch of steps in a wizard to start the small worker virtual machine. And I selected the Ubuntu sort of blank slate AMI, Amazon Machine Image, as the basis for my operating system. Now what I've done is I've selected my small worker machine as the new basis for a new operating system. So I've basically said, make an image of this virtual machine. And so that image has been created. In the previous slide here, I'll show you that we have selected create image, and that creates the image, and it's now accessible to my Amazon account. So that when I go back to the wizard to create a new EC2, instead of using the blank slate Ubuntu operating system image, I can use this, what I've just created from Small Worker instead. So that's what we're trying to do here. Okay, so the image description I put in created from Small Worker, and the new image name is going to be I guess I named it worker or large worker. I'm not sure which. Okay. Okay, so I've sort of gotten a little bit ahead of myself. So now it's this, the title of the slide is Now We Wait for the AMI Creation to Complete. And so it gives us that in-process message. And then we're going to proceed to, let me just take a quick look at this slide. Okay, EC2 instances. Oh, yes, I see. The point of the lower left screen capture is that there is an AMI catalog under the sort of subheading heading of images. And we can use the AMIs to click on that and go find the AMI that we just created from small worker. So here we are at the AMI page of the Amazon Web Services console. And the AMI name that's available to us is something called worker. So we named it worker, and there it is. And it's hopefully got our C program that we created built into it. And we can click on the orange button that says Launch Instance from AMI. And it takes us back to that EC2 creation wizard where we start off by giving our new machine a name. We call it large worker. And the large worker has already had the selection of the AMI being the one we just saved from small worker. Now this time, instead of a C4.large, I chose C5.large becomes C5.4 extra large. And this is going to cost 71 cents per hour. So I'm upgrading to a more powerful virtual machine. And I go through the same process until I get down to the launch instance. And I use the same key pair as before and so forth. And so finally, now we get to a connection to a larger virtual machine. And I'm going to go back to VS Code, and I'm going to go down to the lower left where it says open a remote window. And I'm going to David Valentine. That's not right. I'm going to go down to this open a remote window at the lower left, click on that, and choose connect to host remote SSH. And I happen to know that the very top one here is the new large worker virtual machine. So if I click on that and everything goes according to plan, it will use the same authentication file that we used before to connect to this, this virtual machine. And so now we're no longer on small worker, now we're on large worker. And if I say ls, sure enough, here is the A in the A.c file. If I can even run this executable, and it runs properly. So we have now demonstrated with minimal modifications, so it's a minimal storyline, but hopefully sufficient. We've demonstrated bouncing from a small virtual machine to a large virtual machine. And again, this becomes important if you're trying to be cost effective and you only need a little bit of horsepower, computing power, say to develop your computing environment, and then at some point you're ready to pivot into larger data sets or more intensive computing, and you can simply use this AMI method, this Amazon Machine Image method, to bounce your small working environment to a larger virtual machine to give you that more power. Okay, so that's it. And we've only done this on one cloud. On the other clouds, the process is virtually the same. There's some slight variations in jargon. The technical bit that we ran into here was to notice that the SSH didn't work, and we had to go and change the rules in the security group on the Amazon cloud before SSH started working. I also did an aside on automating this process, both using the command line interface, the CLI, which is the AWS command, and then also a more sophisticated template-based CloudFormation service that works on by virtue of YAML files or JSON. And if you were to follow this recipe in a real research program, then you know, at CloudBank, we would encourage you to take a very gradualistic, step-by-step, make sure everything is okay as you go approach. And if something goes wrong, you want it to sort of be okay that you just delete everything you're doing and start over again. So we're trying to sort of create this. It's okay to start over because this is not a machine that you own. It's just a machine that you're renting by the hour. And then also don't delete a virtual machine unless you're sure that the machine image that you've saved is correct. So it's a good idea to restart it and just verify. Okay. I mentioned that all of this stuff is on the Amazon cloud, but the other clouds have the equivalent technology. This slide is about that jargon, the different jargon that's used. So Amazon uses AMI, or Amazon Machine Image. On Google Cloud Platform, they call it a custom image. And on Azure, they call it an Azure VM image. So as long as you see that word image, you know you're in the right ballpark. The command line interface for Amazon is AWS. For the Google Cloud, it's G Cloud. And for Azure, it's AZ. And these are, again, utilities that you install on a Linux environment. The template building or resource management service names for Amazon, we found that it was called CloudFormation. On Azure, it's Azure Resource Manager, or ARM. And then they cleverly have a higher level abstraction called BICEP. And on Google, it's Google Cloud Deployment Manager. Then finally, we have options for SSH connection to my laptop to my cloud virtual machine. I could have used SSH directly from a Linux bash shell, invoking the PEM file, the key pair file that I downloaded. But instead, I used VS Code Server, which has a little bit of a configuration file step. But once that was set up, I was able to select the IP address of the machine I wanted to connect to, using that lower left greater than less than button. And I'll just mention that sometimes in working with these authentication key pair files, Linux likes to have them have permission of read-only for the user. So there's a CHOWN or chown command that can come in handy. Just mention that in passing. This is a slide from the previous month's presentation. It's a reminder about AWS capacity blocks. If you don't know what those are, it's basically a way of saving money on the cloud by identifying a block of time and a resource that you want to use and kind of reserving that for block use. And then you can pay less per cycle for that resource. So to date, we have had 6 cloud clinics, and this is an expanding collection, and we are looking forward to continue to sort of work on this small topic one at a time approach. And so that's, I think, everything that we have to say today.